Hello everyone, and welcome to the mean value theorem for integration. So the mean value theorem for integrals states if f is a function and it's continuous on the interval a to b, then there exists a number c in the interval a to b such that the definite integral from a to b of f of x dx equals f of c times b minus a. Okay, so what we want to do is draw a little picture that's going to help us understand what this mean value theorem is saying. So let's just draw any sort of function right here. So we'll just call this f of x. Okay, now we want to outline an interval from a to b. So I'm just going to put an a here and an arbitrary b here. And if we look at this first part, the integral from a to b of f of x dx is going to be the area under the curve between the curve and the x-axis and then between these two a and b on our interval. Now what this is saying is that there is going to be some point, we'll just call that point c, some number c, on this interval such that the area is going to be equal to f at c times b minus a. So I just want to draw this straight up, and we get the point right here, and this y value right here is going to be f of c. Now the reason we want to draw this graphically to understand that, if we think about f of c is going to be a height. And it's going to be the height of this rectangle right here. Okay, so we think about that as the height of a rectangle. And then the b minus a, we can think about that as being the width of this rectangle. You see that? So b minus a actually gives you the width of this rectangle. And if we think about height times width of a rectangle, doesn't that equal the area? Well, it does. And so what we're trying to say here, the mean value theorem for integrals does not specify how to determine c or where c is. It merely guarantees the existence of at least one number c in that interval. Now f of c is the average value of the function on the interval. So if we took all these values and we found the average of them, it would be f of c. And the area of the rectangle is equal to the area under the curve. So what this is saying is, if this is continuous from here to here, and we found this average value, it basically accounts for all this extra stuff underneath and over, and it simplifies this into a rectangle. So it brings all these points down and it brings all these points up, and that's what the effect of an average does. And so we're just trying now to determine that there is a c on that interval. Okay, so we're going to take a look at an example, and we want to find the value f of c that is guaranteed by the mean value theorem for integration for the function. And so here we have the function x cubed minus 4x squared plus 3x plus 4. And we want to do this on the interval from 1 to 4. So let's draw that interval. Okay, so we're going to be looking for a c somewhere in here that's going to give us the mean value theorem. So what we want to do is find our definite integral, and that's going to be from 1 to 4 of x cubed minus 4x squared plus 3x plus 4, and this is going to be dx. And we know this is going to equal f of c times b minus a, or the width of the interval. So in this case, it's going to be 4 minus 1, okay, because our interval right here tells us that. Okay, so basically we have an equation now, and all we're looking for is this f of c. Okay, so we actually need to evaluate this definite integral, so we'll use the power rule for integration with the fundamental theorem of calculus. So here we get x to the 4th over 4 minus 4x cubed over 3 plus 3x squared over 2 plus 4x. And we're going to evaluate this from 1 to 4. And we'll just clean this up a bit. 4 minus 1 is 3, so it's 3 times f of c. Okay, so now what we want to do is go ahead and plug in our 4 to all of these, and then our 1 into all of it, and we're going to subtract it there. So let's go ahead and do that. Okay, so all of that, and we're going to subtract, now putting 1. And with this one we can actually evaluate it. So 1 to the 4th is just going to be 1. Here 1 cubed is just 1. Here x squared is just 1. And then here 4 times 1 is just 4. Okay, so this is our definite integral. 4 to the 4th is 256. And then 4 times 4 cubed, well, 4 cubed times 4 is 4 to the 4th, so it's minus another 256 over 3. And 3 times 4 squared is 3 times 16, which is 48 over 2. And then plus 16 minus, add all this up right here. This one gives me 3 over 12 minus 16 over 12 plus 18 over 12 plus 48 over 12. Okay, and all that added up ends up being 53 over 12. Okay, now again you can also use your math frac button on your calculator. So if we added all this up, we would actually get 56 over 12 minus 53 over 12. No sense in killing ourselves with that if the calculator can do it, because that's not our focus, adding fractions. And so this, I'm going to bring down the equals to 3 f of c, just so we have that as a reminder. And this gives me 57 over 4 equals 3 f of c. And let me just rewrite that over here since I ran out of room. Now, again, the goal here was to get the value of f of c, so now we're going to just divide by 3 on both sides. So we get 57 over 12 equals f of c. Now that f of c, if we do 57 over 12, that's going to equal 4.75. And I want to show you how this relates now to our drawing. So let's find 4.75 on here. And it looks like it's somewhere, well, that's 4, there's 6, there's 5. 4.75 is right about here. And that's our f of c. And so what that means is, when we look at this, okay, we have a function and f of c equals 4.75 right here. So if we were to map this down now, this right here would give us our x value of c. So here we have c, f of c, and notice that c is on our interval, and we got our value of f of c. Now remember that that f of c right here is the average value of the function. So that if I drew this rectangle out, okay, I could take this width, which was 3, and then this height, which is 4.75, and if I multiply that together, I get this indefinite integral right here, which would be 57 over 4. Now, this problem doesn't ask us to find c specifically, but let's go ahead and talk about that because I'm curious. Here we had our f of c, it was 4.75, and we want to know, well, this function, where does this function equal at? And that would be finding our c value here. So how would we go about doing that? Well, we do know that f of x equals x cubed minus 4x squared plus 3x plus 4, and we also know f of c is 4.75. So if we just replaced some of these values here, we would know that f of c equals 4.75, which would equal c cubed minus 4c squared plus 3c plus 4. So all I did there was substitute c in for our x values. And since I knew f of c equals 4.75, I can set these equal. Now, solving this might be a little bit tricky, but if we did solve it, we would get c. So we're going to use Wolfram alpha here. All right, and Wolfram alpha can solve equations for us. So if I just type in this equation, it will give us an answer for c. So 4.75 equals c cubed minus 4c squared plus 3c plus 4. Okay, so it gives a lot of information. It shows some factored forms here, but it gives us a real solution of about 3.11394. And that is an approximation there. And if we look, we'll see that our c value does fall at about 3.11. Okay, so that's how you find the value f of c, and then also how you find the c value that will give you the f of c. So in example 4, now we're going to be asked to find that value of c that is guaranteed by the mean value theorem for integration. And we're going to do that by following the same process as before. And if we can come up with f of c and we know our function, then we could actually solve for what c has to be. Okay, and so let's go ahead and find the value f of c that's guaranteed by the mean value theorem. Okay, so I want you to go ahead and give example 4 a try on your own, and when you're finished you can come on back to check your work. Alright, welcome back. So let's go ahead and check your work here. So the first thing you should have done is just draw your intervals here, kind of showing what we're looking for. And then we can set up the mean value theorem. So we have the definite integral from 4 to 9 of x to the 1/2 dx. Notice I changed the square root to 1/2 because it's a lot easier. And that's going to equal f of c, or our average value, times 9 minus 4, which is the distance in between the two intervals. Then I went ahead and evaluated my definite integral here. So you can see the power rule for integration, and then the fundamental theorem of calculus right through here. And then what we came out to was that f of c equaled 38 over 15. Okay, and you can see the height, 38 over 15, right here. Okay, then if we wanted to find that value of c that gives you your f of c, then we just set it equal to our function. So the square root of c equals 38 over 15, and we're going to solve that by squaring both sides. And so we got C to be approximately 6.417, and you can see it does fall within that range. Okay, so this is how to find that value of C, which is guaranteed by the mean value theorem.